Okay, so let's start actually the talk. So we'll be talking about what you can do in Android Shell. I have to say that this will not be talk about Android SDK. You know that you have a lot of tools in the Android SDK, command line tools. But we'll be talking about what you can do actually after you invoke the only SDK tool, ADB, Android Debug Bridge, and invoke the command ADB shell. And what you can do directly on the device, on a machine, on a separate machine, and how these commands available on an Android phone can help you in Android development, Android applications development particularly. So before we start, let's please raise your hand if you attended the Binder talk at the beginning of this conference. Right, a few of, okay. And so I will just briefly remind you, because this is actually a continuation of that Binder talk, because what we'll be talking about and demonstrating here is actually deeply relies on the Binder framework. So if you take a look at Android, you will see that there is a special process that is called system servers that starts on an Android system. And this system server has a bunch of different system services exposed to different applications. These system services have a special methods that you can use to interact with them. And when you develop an application, you have an SDK. Usually you have a bunch of different managers, as we call them, as we know them. For example, alarm manager, notification manager. And this SDK actually translates the codes to Java methods, to binder transactions, to interprocess communication that communicates this your intent to, intent as an action, to a system server to tells the system server what to do. And actually, there are a lot of different processes in Android that expose different system services, and not only the system servers. There are a media daemon or a keystore daemon, and all of them communicate different using an interprocess communication using the Binder framework. But what we'll be doing here is using shell environment, shell commands, and the difference between interconnection between the shell and system server and between the application and the system server is that they are run as a different Linux users. You probably know that every application has a dedicated Linux user ID on a system and runs as a separate Linux user. And thus it has a separate set of permissions. The shell user is a separate user. And the clients that we have for interacting with system services usually have more permissions than a regular application user. Hence, with the shell environment, we can do more. We can do some stuff that is not available to applications. So let's start with the shell, actually. You have already seen a simple command that you can invoke in Android Shell to list all the available system services. I will remind you, it's a service list. And the point is that there are a lot of different system services. But let's go further and try to actually communicate with one of these system services. I'm currently playing with my personal device, so all these commands can be performed on a regular Android device, not on a rooted device, because when you have a rooted device, or for example, in an emulator, with shell you actually can do everything, because you can get root permission and can do really scary stuff. But here we'll be working with the regular phone and see how shell commands will help us with Android development. So this service command has another argument, another variation. You can actually communicate with a particular service. You can type service call, then type a service name. This one particular is a status bar. There is a special system service that is called a status bar. This service doesn't have a dedicated manager like alarm service or notification service, but it is present and other system components can use it to communicate with the system status bar in the system UI. And we'll try to call to invoke a binder transaction with the code 1. it actually corresponds to a Java method in the system service, which is called expand. So basically what I have done is code a Java method in the system service, which is called expand on a system's status bar service. If I type 2, I can actually collapse this status bar. So I communicate with the Android shell regularly every day, and this is how I can spend my day. Animations are pretty, hence I can expand and collapse this status bar all the day. But having this fun, you can see that you actually can remotely control this system bar. So if you want to make a joke with your friend, you can configure DB connection over Wi-Fi and expand his status bar just to have fun. But let's get to more serious stuff. So Android shell has a very useful command which is called dumpsys. Raise your hand if you have used it. I believe that you have. Yep. And basically what this command does is also taking a service name as an argument and invoking a special dump method on that system service. It helps understanding the internal state of this service. So basically, if, for example, we invoke dumpsys alarm, we'll get a huge output describing all the internal state of the alarm manager of the alarm system service, listing all the different pending intent that must be scheduled, probably viewing time. But this is more useful for a system developer who is checking whether there are any bugs in the Android system. What is more useful for us is a special meminfo system service. If you call it without any additional arguments, you will, and give it some time, you will see a list of all the processes running on a device ordered by the memory used by this process. Hence, you can see actually a top list of and see whether your application is in the top list of by memory usage. So you can see that Google Quick Search box is currently on the top. Twitter application is if it is in foreground. Usually, foreground process can be found on the top of this list. But what is more useful in this command is that you can type a package name of your application and get more information, more insight about your particular process. So, for example, let's take a look at the Twitter application process. You will find that it dumps information about the size of its Dalvik heap and native heap. The Dalvik heap seems to be not that useful because you have a great Android Studio instruments to analyze how your memory is used to spot the memory leaks. But if you deal with the GNI code, the native code, this method is probably the only way to understand whether you have memory leaks in your native code. Because if you know, you can tell me, but I personally do not know another way to understand what is the size of my native heap. Another useful piece of this output is a list of open database connections. So, for example, from here you can see that Twitter applications, for some reason, we do not know why, we can only speculate. It has multiple databases used in the application. Probably it is connected with the backup mechanism of Android system and how they deal with backups, but we do not know, can only speculate. Another piece of useful information is asset allocations. This will list all the open assets from your asset that you open with Asset Manager. Pretty useful when you deal with custom fonts and do not want to allocate one typeface multiple times, because it is actually not what you want. Typeface must be always kept as a singleton. And a few years ago, we had a bug in one application that after a frequent use of application, device rebooted. It was on Android 2.3, but it was connected with the fact that we are allocating a typeface every time we were displaying a view. And as a result, the native memory that was backing these assets was growing too large, and Android was restarting to get some resources. So if you allocate the same font multiple times, you will see it a duplicate in this list. Twitter doesn't. Good job. But let's get, it was a bit boring probably, let's get to more interesting stuff. With the dumpsys battery command, you can mock the battery level of your device. Let's take a look. First of all, let's get some information about the device battery. If you type dumpsys battery, you will see that you will see what type of a charger is connected to a device. In this case, it is a USB charger. You will see information about the status. 2 means it is charging, it is being charged. Health means healthy. The health can also contain information it is too cold, overheated, or something like that. And it has information about the current battery level. So first, the first thing I will do is I will make the system think the charger is not connected. This can be done with a simple command, set USB 0. USB is my charger type, hence if you take a look, screencasting doesn't work very well. But you will see that now USB port is false, meaning that we do not have USB charger anymore. Now let's try to pay attention to the battery icon. You can see that there is no flash icon over the battery icon. I can switch it back, set USB 1, and you will see the flash icon. So another part of the game. And finally, let's tweak the battery level, and for example, set it to 5%. You can see that now battery server is activated on my device. This is actually the most dangerous part when Wi-Fi is reliable. It is the most dangerous part of my presentation because in these conditions screencasting can crash and I do not get any picture anymore. So when you are done with your gambling with battery level, don't forget to invoke battery reset because otherwise the system will be thinking that you still are not connected to a charger or your battery level is still, for example, 100%. And will not shut down properly. But don't worry too much. I don't believe it will actually harm your device. Another trick suggested by my friend is that you can actually set the level to 100% and then show to your iOS friend and prove that Android is better even without standby mode and those. Now let's take a look at another service called Activity. So if you type dumpsys activity as usual, you will get a huge output about the current activity manager state. It will give you a lot of information about what tasks are currently running, what is the current stacks of tasks, and so on. So again, useful for system developers, not that much for application developers. But what is important is that you can give more information about a particular process, a particular package. For example, let's take a look at what services are running for Twitter application. Activity service, and I will pass package name com.Android. So right now we see that there is one service called async service running by Twitter. And what is important is that there is a special section which is called client. We can see that there is nothing to dump label. If you implement your custom application service, there is always a protected method called dump that you can implement. And if you implement this method, you can dump your internal state of your service and have a quick way to see your internal state of the service you are developing using the command shell. This actually can be used for automation because you can automate some checks, some useful checks, and see, for example, if your service is running at some moment or it is not running. And again, you can automate this. Let's move forward. So this was a dumpsys for activity service. Another command that is available in Android shell is Activity Manager Client. This is a special this a separate program that you can run to send new intents to the system and actually start a new activity, start a new service and a broadcast. This is very useful when you want to get to some particular point of your application. For example, start a particular activity. You can do this, of course, with an Android Studio. You can specify what activity to launch when you run your application from the IDE. But what you cannot do in Android Studio is specify extra parameters of the intent. You cannot specify extra some category or start a service. This is not possible from the IDE. With this command, with Android shell, we can do this and get straight to the point that we can test or debug. So to demonstrate, let's take a look how Twitter handles HTTP links open from the browser. So let's grab one. This is a link to a tweet about the time speaker. And we'll try to launch a Twitter with the command am start. Start will launch an activity. Action will be Android intent action view. We know also that when a browser launches such an intent, it includes a special category, which is called Android intent category browsable. And of course, we insert the link as a data, as an intent data. So all these command line parameters specify our intent. And if screencasting works, it doesn't work. A bit laggy, sorry. So I will try to run it again, probably you will see the picture. Basically, Twitter starts and displays the activity that displays my the tweet that we are linked. What is more important is that we can combine this with the tweaking system settings. There are two kinds of system settings in Android. Both are not editable from applications, but we can tweak them from the command line. The first one is system properties. System properties can be modified and read and write using setprop and getprop commands. And there is a particular system property, debug layout, that will instruct their hardware renderer to draw the layout bounds of your views. You actually have seen this at one of the talks. You can switch this on in developer options of your phone. But with these commands, you can actually automate this switching on. And if you have some tests, some automated tests that make screenshots that you can review after the test runs, combining this with such commands, you can give additional insights from your test runs. You will see the screenshots with layout bounds, or you will see screenshots with hardware overdraw information. And just reviewing the screenshots, you'll get some insight about your application performance. I will probably not risk to demonstrate this using screencasting because it basically doesn't work. And another useful command is a simple intent protocol that you can use to tweak your status bar. So behind the scene, this system UI has a special component that implements a very simple intent protocol. Basically, they react on broadcasts with the special commands and can allow you to make this status bar to enter some special demo mode. In this demo mode, you can configure the status bar as you wish. You can, for example, hide all the notifications. You can display Wi-Fi indicator, or you can switch off or hide the network information indicator. This will work on a device and is very useful for screenshots. For example, if you want to remove an ADB debugging icon from your status bar, you can use it to use this intent protocol and do it. And Android open source project actually has a special application which is called systemui.demo controller that you can try build and install on your machine using just a dragging gesture. You can configure a status bar in different modes. It will react on your dragging, and you will see that different Wi-Fi levels and different network types are displayed in the status bar. You can see the protocol there and actually make your own app that will configure your status bar as you want, for example, to automate something. And you can only imagine how this all can work together, because you actually can. You have a command to configure a status bar. You have a shell command to make a screenshot. You have API to submit your application and assets to Google Play Store. Hence, you can actually fully automate the process of publishing your application with screenshots, and all this will be automated. A brief look at other commands. Dumpsys appwidget will be very useful for launcher developers. It's a good source information about how your application, how your custom launcher uses third-party applications widgets. And dumpsys content will give you information about all the sync adapters configured in the system. And you will see when your sync adapter is scheduled to be started next time. You will see information about a history of how your sync adapter was triggered. And you have a special command requestsync that you can use to trigger synchronization on some account. So I hope that I managed to, despite the problems with screencasting, I managed to convince you that Android Shell is very useful, and you can use it for fun, you can use it to learn, because Android system is very fun to investigate, to discover, and of course to debug and test your applications. Thank you for your attention, and I will be glad to answer your questions.